Everybody, it's Tyler here at the Space City Signature event, checking in with 3118B Astrobots, local team here, who's been having a great run both throughout the season and, of course, here at this competition as well, too. Already tournament champions, so congratulations on that coming into this event. So a lot of great stuff we'll be talking about. I think one of the great things we'll be covering, too, is just kind of some of their different iterations they've gone through. Earlier, they tried doing a Tier 3 hang, made some changes for this event, and they've even been making changes during this event as well, too. And one of the things I really want you to pay attention to later on during the interview is some awesome graphing they're doing, but actually following the robot during a match, getting some great data out of that as well. So let's learn more about this team coming up here on Pits and Parts. So Jonathan, let's talk about some of your iterations coming into this competition. We were talking earlier, you tried going with like a Tier 3 climb and a hood, that sort of thing. So I'd love to hear about, what changes made, maybe why you didn't go that route. And then also I noticed you got a goal rush mechanism on the front too.
So before we came into this tournament, we had a completely different robot. We completely rebuilt the robot over the weekend because before this we actually had a hood robot that also included a Tier 3 hang. So we've been developing a Tier 3 hang for the past couple of weeks, and so we've had good success with our linear slides and our PTO mechanism. It's just we couldn't quite get the attaching onto the ladder part right. A lot of times we would fall and it wasn't very consistent at all. We were kind of scared that our robot would keep falling off of the ladder, so we decided to not go that route anymore because it was very heavy with the Tier 3 climb and the hood. So we wanted to make sure that since we're going into a signature event, we wanted the best chance to, we want to do as good as possible. So we realized that having a light robot that's fast, that will be the best option for our robot. And then, so another thing we also noticed that why we did a Tier 3 climb is we really broke down the game when the game manual first came out. So we realized that Tier 3 climb, even though it's a super hard task to do, it gives a bunch of points, like 12 points in a game where most people are only scoring 20 to 30 points. That's a huge bonus. So we realized that going a Tier 3 climb route, working on that early ever since the game manual came out, that would be a good choice for us. But we realized that it wasn't going to work out too well for us. So another option we decided to go through is using a goal rush mech. So we realized that getting the third goal during the match is usually like one of the 3 ways you can consistently win in this game. So we realized that having a goal rush mech could be super useful for us getting that third goal, especially during Auton. And then so basically how our goal rush is powered, we have these 2 pistons. One of the pistons deploys the goal rush. This goes all the way out to 24 inches to make sure that we're using our space as efficiently as possible. And then we have another piston that clamps the goal. And this clamp is also pretty sturdy. Other teams have been trying to deploy stuff to try pull the goal, but since this clamp is actually clamping on the goal instead of just like hooking on the top, we can actually pull those goals out of other teams' doinkers. And then so this goal rush mech also doubles as a doinker for clearing out the rings inside of the corner. Just with this little plastic piece over here, we've had some great success using that.
So something I want to ask, you're now here at day 2 of Space City Signature event. Are you happy with the changes so far, and or would you potentially still consider going with a Tier 3 hang later on during the season?
Yeah, definitely. We definitely would consider going on a Tier 3 climb later in the season. We are also happy with our decision to rebuild the robot over the weekend. This has been working a lot faster and more efficient than our hood robot we had. And yeah, going with the Tier 3 climb later in the season, we know what we want to revise and what new additions, new iterations we want to do in a Tier 3 climb, and we possibly would want to do it for our regional champs and state competitions.
Well, I haven't seen what your prior robot looked like, but this robot's looking great so far. So at least from that end, I think you've made a great decision that way too. Let's pass over to Ben. You talked about a little bit on the plastic here, so I'd love to hear more about some of this different plastic you have cut in here as well too. Your team has done some powder coating as well. I'd love to just hear about, if teams want to get into powder coating, what can they do or how do they get started?
Yeah, sure. So starting off with the plastic, as we sort of developed as a team and gained experience, we started CADing our robots, and so we could create more complex mechanisms and connections. And so you can see with certain parts of the robot, such as the gussets here and the intake, the Lady Brown hooks or the intake ramp, we started using more and more plastic because we could make really quick modifications and also have sort of that complexity of being able to put parts in the perfect position, especially in CAD and both in real life. And so as we kept on developing, we were able to create a robot that was both lightweight and functionally effective. And focusing on the powder coating, it was sort of one of our goals going into senior year to make our robot look a little bit cooler while being functional. And so one of the colors we set on was white. And so powder coating basically uses a powder coating gun and an oven. And so it's really accessible for most teams if they wanted to get into powder coating, because all you need is an oven essentially and the powder coating equipment. And so we sort of built the plastic and the powder coating into our timeline, so it didn't take too much time in building our overall robot.
You mentioned that you're doing CAD work for your robot too. What do you CAD in?
We CAD in Onshape, and so we split up each CAD part between our members so we can effectively integrate the robots and get the robot done in time.
And I don't know if a lot of other people know, but Onshape, a big advantage, as you mentioned, right? It said it's all cloud-based, right? So you can literally run it on anything. Have you found that to be a big advantage for your team?
We did find it to be a big advantage because we could have people work on the same assembly at one time, and so we can make changes in real time and see those updates in the assembly.
Speaking about changes, Winfred, you all made changes even here at the competition as well too, right? Like it wasn't even just before. You've been making iterations throughout this competition. Talk to me about what changes have been made.
Yeah, just two really small minor changes, but they've actually been really helpful for us. So it's really just right here, this chain tensioner, and how we rotated our wall stake mechanism. So when we came into this competition, so this tensioner wasn't here, and what would happen is that when these rings would go on the hooks, it would make the hooks dig down into the chain like this, and then when they would go over like this, they would just gain like that much momentum, and then it would just fly out. And it actually was pointed out to us, and we didn't even realize that was what was happening, but it was a really big help for us, and now our intake is a lot more consistent. Yeah, and just having that tension there just makes sure that the ring doesn't affect how much the chain kind of wobbles, and then the ring won't fly out as much. Yeah, and so here on the wall stake, these plastic pieces, they used to be rotated about 90 degrees, so that way this hole right here was actually like right here, and it was kind of not sticking out as much this way. And so we kind of realized that the rings weren't getting stopped enough, and they were just kind of falling out while we were rotating like this. But we just tried to, initially we were kind of worried that this might not be wide enough to hold the ring, but just having it stick out this much, and we'll have the ring just stay in while we're rotating and it gets into the wall stick.
Jess, we really got to talk about, I think something I was really wild with was how you're actually getting data from your robot during matches as well too. So we have actually a graphic on your computer as well that we can check out on how you're graphing, taking some of the odometry data and GPS as well too. Talk more about what you're doing, and more importantly, like what benefits is your team actually getting out of tracking this sort of thing?
Right, so one of the things we wanted to do this season is like, a thing we've explored in the past is taking some of the data off the robot and putting on our computers to look at later. So in the past, we've used like a simple like Excel spreadsheet kind of deal, where we just put all the data and like just pure numbers into a spreadsheet and then graph that to look at it later. But the issue with that is you either like, you can put values on the brain, but you have to be there to see it. And you can put values on your computer, but then it's just like a couple things. So if you have some data, but you needed something else, you've just lost that data. So the concept behind this was that we could put everything on our robot onto an SD card and then read it later, like in real time, so we can actually go through and see like during the match, this is where our robot was on the field, this is where it was running auton, this is where we clamped down to goal, that kind of stuff. And we can actually go through and say, hey, the intake heated up at this point in the match, so it stopped working here because it overheated. Or we can say that the joystick stopped working, or we can track every issue on a robot back to a certain input or part of the motor or sensor or something, and say this is where the issue came from. This is also really big for autons and like tuning PID and stuff, because we can go back and look at the individual data for like each of the inputs and each of the outputs and say, this is where we started pushing the button and this is where it started turning, but it overshot the turn by a little bit and came back. And we can look at that data and make adjustments based on that, allowing us to know everything that the robot's doing and when it's doing it.
And from that data you're getting back to, do you utilize that both for skills and for competition field play?
Right, yeah. So every time the robot turns on, it collects that data, and it's really big for just like I said, tuning stuff and making improvements to autons and repeatable things. But whenever there are issues, like I said, even during driver control, we can say that this is where that issue came from. So it's just good for just fixing issues as the competition goes on and making improvements.
Well, 3118, thank you so much for telling us more about your robots here. I love to hear about all the updates for it. I think what you're doing from this side is great too. So, of course, we can't wait to see how you do here at Space City, but go out throughout the rest of the competition season, and we hope to see you progress throughout the rest of the way. Thanks a lot.
Thank you.